On number 1, what rule am I going to apply here? 5, 4, 3, 7, 6, what, number 1, 2, what rules will I apply? 1 and 2. Exactly. Rule 1 has to do with 0 exponents, if I'm not mistaken. So I'll use rule 1 for that one because that's the 0 power. And I'll use rule 2 for these, rule 2. Okay, that's it. We'll be done. Let's see. Let me write the fraction bar. This will go to the top of the positive exponent. This will go to the bottom of the positive exponent. This will turn into a 1. And we're pretty much done. Just got to simplify. N to the 4th times 1 is just n to the 4th. That's cool. Over 7 squared. And if you have a base that's a number, just go all the way with the exponent. So we'll have n to the 4th over 49. We're rocking and rolling. Now, those of you who are absent Monday and Tuesday, you will catch up with the notes later on and watch some Google Classroom videos to get you caught up. Let's try number 2. Okay, so let's see. Number 2 has nothing but negative exponents. So this is all going to be rule 2. Let me write my fraction bar. I got t to the negative 5th power, which will go to the bottom of the positive 5 power. 8 to the negative 2 will go to the top of the positive 2. S to the negative 3 will go to the top of the positive 3. We're pretty much done now. Let's just simplify bases that are numbers. 8 to the 2nd power is 8 times 8. That'll be 64. So our final fraction is 64, s to the 3rd power over t to the 5th. Cool. We have a number 3. Now, number 3 may give you nightmares when you see it, but it's going to be okay. I'm going to go slowly, one step at a time. But now we're going to shift into high gear. Now that we know all of our 7 rules, here's number 3. I'm going to write that down. Look at that puppy. I'll give you about a minute to write that down. It's number 3. That looks hideous. That looks gross. It's inducing vomit. It's so nasty. That's those. So you should have those out so you can see. When I go through this and I say rule number 5, you can look at it and get familiar with the rules. That's what a wise student would be doing at this point. But I can't force you to be wise. Everyone has a right to be foolish under the Constitution. So I can't force you to be wise. Here we go. Let's do it. Here we go. What rule out of the 7 involves a bunch of stuff inside parentheses that even involves division and then raised to a power? The last one, which is, I think it's called the quotient of powers or power of a quotient. Power of a quotient, right, Ayala? Rule 7, is that power of a quotient? Yes. Okay, so watch this. That rule says every single thing in the parentheses, both numerator and denominator, can all be raised to that power outside. So I'm going to do that first. Watch this. 5 squared. X to the, look at, this is already to the negative 4, and it's raised to a power. So this is really the 5th rule, power to power. Look at the 5th rule. Power to power, you multiply those puppies. Negative 4 times 2 is going to be a negative 8 power. Y to the power, that's 5th rule. So right now we're combining the 5th rule and the 7th rule together. It's a combination of the two. So this is going to be y to the 6 on the numerator. Cool. Let me put the fraction bar. Estrada, what will this 2 be raised to? What should I raise a 2 to what power? Okay, it's already to the 1, but what should I raise it to now? Using rule 7. Turn off the music too, by the way. Perez, help him out. 2 will be raised to what power? Okay. Alvarez. 2 or 4? Right, because look at here's 2. I'm raising every single thing to the second power. So this will be 2 to the second power. X to the what? Alvarez, what do you think? X to the what power? Sorry. Alvarez? Wait till when I call on someone else. You're awesome, though. I love you. Yeah. 2 times 2, power to power. So it'll be x to the 4th. Valero, y to the what? Let's see. 0 times 2, definitely 0. Good. Moving right along. I'll bring down the multiplication symbol. Times. And now over here, I'm going to use the quotient of powers also. No, power of a quotient, number 7. Salazar, 4 to the what power? Nice. Sikaitos, x to the what power? Excuse me? Thank you. Castro, y to the what power? Nice. Rodriguez, y to the what power here? What do you think? That's fine. Ayala. So power to a power. So it's already the 3rd. I'm raising the power. So nice. So that's the 5th rule again. And we're rocking and rolling. So far, so good. We're nowhere near done. We've got a lot of work to do still. But any questions on the first step here? By the way, the problem of the week, outside if you do, it's worth 1 whole assignment or 2 stamps. It's worth a whole day of productivity. That problem of the week is a reflection of this problem, but a little bit more detailed. So if you want, for those of you who are courageous and you want to try that later, knock yourself out. All right, let's do it. So I got a nasty fraction times a nasty fraction. And if I remember my rules of fractions from junior high school, to multiply a fraction times a fraction, it's numerator times numerator, then denominator times denominator. We could if we wanted to. Let's for sure, yeah, simple. What do you mean is 5 to the second power? Let's do that first. Yeah, for sure. One more time. What do I what? Go ahead. Okay, we could. We can take this to the bottom because it's a negative. Or when we multiply, look at these are same base, and I'm multiplying. What rule involves same base and multiplying? First, second, third, fourth, or fifth? Same. So it's a. Which one is the product of powers? The third one. The product of powers. Look at product. It will be multiplying x to the negative 8 times x to the second power. The product of powers rule says we can add the exponents. Negative 8 plus 2, and we'll get there right now. Or look at quotient of powers, which is rule 4. Quotient of powers is rule 4. Look at dividing same base. I can subtract negative 8 minus a 4. There's different ways of going about it right now. I'm just going to go through one for now. Tomorrow I'll do a different way. So right now what I'm going to do is I'm going to go numerator times numerator, and then denominator times denominator. But before I do that, let's take 5 to the second power all the way. So 5 times 5 is 25. So let me rewrite the numerator as 25 x to the negative 8, y to the 6th, all over 2 to the second power is 4, x to the 4th, y to the 0 power is what? 1. So I'm going to put times 1. I'm going to use the 0 power property, the first one right now. It always becomes 1. Times, nice, 4 to the second power is 16. I got x squared, y squared, all over y to the 6th. All right. So numerator times numerator, denominator times denominator. But before I do that, if I take 25 times 16, I'm going to have a nasty, nasty, huge number on top. So what I'm going to do is I'm going to cross multiply or cross cancel. From junior high, your teacher taught you how to cross cancel. If you're multiplying fractions, you can cross cancel to make the number smaller. In other words, look at 4 goes into 4 once, and in the 16 4 times. Cross canceled here, which is really simplifying before we even multiply. Yes, sir. Here, that's the zero exponent rule that you missed, that you're going to take notes on later. Anything raised to 0 power is automatically 1, to answer your question. All right, so here we go. So I cross-canceled the 4 and the 16. We're now ready to multiply now. Numerator times numerator, denominator times denominator. Let's see what we get. Before I do that, any questions? I'm getting, some of you are like with me, like no problem. Some of you I have like a, you guys ever ran over a deer at nighttime? The headlights? It's like, I don't know what to do. I'm getting that look from some of you. You're about to get run over like from a freight train. Sellers are already run over. She's gone. She's on the road. Roadkill. No, it's good. Let's do it. 25 times 4. Awesome. Castro, thank you. Ready, Ayala? All right, here's the third rule that Beltran mentioned. Product of powers. So x to the negative 8 times x to the second. Adam, hit it. You're awesome. Right? Negative 8 plus 2 is a negative 6. We're adding them. And now, same thing. Y to the 6 times y to the second. Someone besides Castro. What's y to the 6 times y to the second? Nice. Y to the 8. All right, we took care of the numerators. Let's take care of the denominators now. 1 x to the 4th times 1 is just going to be x to the 4th, right? So this is just x to the 4th at the bottom, because 1 times 1 is 1. Done. X to the 4th times y to the 6th will just be x to the 4th, y to the 6th. I'll stop there. We're not done yet. Let's not get all happy. Any questions yet, though? We'll stop on the road before we get to our destination. Any questions here? So that was just rule 3, product of powers. Okay. Let's do some cleaning up now. We're almost done. What do you guys think? What rule can I use now to finalize this? What do you think, Sagaido? Talk to me. Hit it, Perez. Rule 2, negative exponent rule. We could do that. Balero, what were you thinking of? I think you said something. We could, right? But what I noticed, so check this out, Perez, even though we could do that, here, let me put a cloud around here real quick. I want to show you guys something. Because I'm going to go 2 routes. It's like if I'm going to go to downtown, I can take the 60 or I could take the 10. We're still going to get the same place. I'm going to use your way, and I'm going to use another way first. But let me take the 60 first to downtown, then I'll take the 10 freeway to downtown. I'm going to show you two separate ways to deal with this. What rule involves division and same base? Okay, same base, x and x. What rule is that? 1, 2, 3, 4, 5, 6, or 7? 4, which is quotient of powers. Quotient means division of 2 powers. What do I do with those exponents? Careful. You subtract them. So I'm going to take x to the negative 6 minus 4. And same thing here. Look at y and y. It'll be 8 minus 6. So look at my final answer. Watch this. 100 times x to the negative 6 minus 4 power, y to the 8 minus 6 power. Right? Because I'm just subtracting the exponents at this point. That's just rule number 4 that Ms. Castro mentioned. Let's keep going. So my final answer then will be 100 times x to the so negative 6 minus 4 is going to be a negative, that's negative 6 plus negative 4, negative 10 power, y to the, nice. So technically we're done, but it's bad manners mathematically to leave your final answer with a negative exponent, so now we're going to use a negative exponent rule. Say again? Well, no, I don't have to worry about the bottom because I used the rule. All this, look at all this became this. Did it not? Right. So all this is over 1. So now let's rewrite this now with a positive exponent. All positive exponents. Yeah, language. Yeah. Thank you so much. Careful. I'm only going to move terms or factors that have negative exponents. There's only one factor that has a negative exponent, and it's x. So that's the only thing that's going to move to the bottom. So watch, this is my final answer. 100 y to the second over what? X to the 10th. That the exponent turns positive. We're done. Whew. Dang, that was crazy. Now, I talked about the 10 freeway and the 60 freeway. Let me use Perez's method back over here in this cloud. Remember at this point in the juncture in our journey, I said, what should we do now? Perez said, hey, this has a negative exponent, and I think you mentioned that too. Why don't we deal with the negative exponent? And let me do that first. Let me bring this down. Let me take a different route now. Stay with me. You don't have to copy this down, but just watch. I'm going to take a different route. See if you like this route. All right, so let's see. Whatever has a negative exponent will move across the fraction bar. So this is the only thing that has a negative exponent. So let me rewrite this. I got 100 y to the 8th on the numerator. Look at on the numerator over, watch this. This moved to the bottom with a positive 6 exponent. So I have x to the 6th, and I still have x to the 4th at the bottom, and I still have y to the 6th. Look what I did. I used that negative exponent rule. And now look at the what we have here. Product of powers, rule number 3. Same base, add the exponents. Look what I got. So I got 100 y to the 8th over x to the 10th. I add the exponents, one of the same base, and I'm multiplying. Y to the 6th. And now look at same base, rule number 4, quotient. Look, I'm dividing the same base, subtract the exponents. So my final answer will be 100. 8 minus 6 is y to the 2nd over x to the 10th. Same thing. I don't know. I was just doing the rules. What do you think? Let's see. Same thing. I mean, whatever you prefer. The moral of the story is, as long as you use your rules correctly and logically, you can take different routes to the final answer. Just like the 10 freeway and the 60 freeway meet in downtown LA. Okay? All right, so what I'm going to do now is I'm going to release you to grab your Chromebook. You're going to go to Google Classroom. You'll have your stamp sheet in front of you, and you're going to figure out how far away you are from exactly 1 credit in my class, which is going to happen today. And if you're deficient, you're going to write down an idea of how to catch up on stamps. I'm taking these stamps seriously. I encourage you to take them seriously because at the end of the quarter, there's this one veteran student. You remember my story?